is being used very heavily in the industry, right? And it can process millions of events. Everyone knows that. But in real systems, there are some challenges, right? Today is the video which where we will discuss all those challenges, right? For example, in microservices environment, right? Have you ever think if your consumer service is down for, let's assume, 2 hours, right? And the other services are continuously ingesting the data into Kafka, right? How the consumer service would behave when it comes up after 2 hours and it sees, okay, there are millions of events to process, right? How the consumer service would handle this high surge of requests. This is one of the challenge. The other challenge could be how you would roll out new application version, new service version, right? Which will have the performance benefits and other more rich features, right? How you will test those new app with the real production data without any risk, right? How you would deploy this new app version with zero downtime, right? That's what blue green deployment is, right? Today is the video where we will discuss how we can achieve zero downtime deployment with respect to Kafka in real distributed systems, right? Now the other challenges could be your service might have some issues, right, due to which the data doesn't get saved into the database, right? Or there are some major problems, right? Now how to replay all those messages. So in this video we will discuss all those challenges, not only theoretical part, but I will implement practically each and every case, and I'll show you how easy it is to implement actually, right? So without wasting time, let's get started. So for this video, few concepts which we have studied earlier in the Kafka Zero to Hero series required to be known to understand all these use cases, right? So the first concept is the consumer lag. So the guys who are very new on my channel, I would highly request them to watch my Kafka series, and specifically they have to watch the Kafka videos 5, 6 and 7, right? There I have covered each and every concept in very much detailed depth and with all the practical implementation and trade-offs, how it is being actually used in the industry, and I have really gone in depth how Kafka is doing all these things internally, right? Which will be very helpful for the interviews as well as for the troubleshooting when you face the real problems in the distributed systems, right? Now the just for safer side, I'm just covering the consumer lag because it is very much necessary for this video, right? So that the guys who are new on my channel, they also can understand this video, right? So what is consumer lag? Okay, so we have studied Kafka. There is a publisher in Kafka, there is a consumer in Kafka, right? And publisher publishes the message onto the topic. As you can see, the order service, it is publishing the messages onto the Kafka topic. Kafka topic resides where? On the Kafka server, right? And the other side, we have consumers who continuously poll the messages from the Kafka topics, right? For example, this is the product service, the inventory service, shipping service. They are the consumers who want to consume the order events from the Kafka topics, right? Now where does the consumer group fall? Consumer group is very effectively used for scaling, right? So if you have 3 instances of the inventory services or the 2 instances of the shipping services, so that 2 instances both can continuously poll and get the messages and process it, so it helps in the scaling, right? Now I'll just show you how practically the consumer lag is, right? So without wasting time, let's see the demo, right? First of all, I need to bring up the Kafka server, right? So I have already shown how to bring up the Kafka server. I have created my own image, right? So just docker compose up, right? Now with this, the Kafka container would be up and running, right? Now once it is up and running, we'll just create few topics, right? For example, now if I can see docker ps-a, the Kafka container is there. What I need to do, I just need to go into this container, right? Now once I go into this container, I have created the Kafka bin directory there, right, where the whole Kafka bundle is available, right? Now in this, what I can do is Kafka topics, right? This is the CLI command which is given by the Kafka, right? And for connecting to Kafka cluster, right, what we need to do, we need to do bootstrap server, right? So bootstrap server, I have mentioned, that is very much necessary for connecting to the Kafka cluster, localhost 9092, where our Kafka server is running. Let's see the list, how many topics are there, right? Bootstrap server, okay, localhost 9092. Boot, okay, my spelling is galat. Yeah, now you can see there are no topics created, right? So what we will do, we'll just create few topic or one topic, right, to understand it, how the consumer lag works, right? So topic, we can give the topic name, right, the order events. Let's take the same example, right? And here is the create command, and how many partitions we want there, what we mentioned, okay, the number of partitions we want for this topic is 2, and we want to create this topic. Let's create the topic, right? So the topic has been created, right? Now the topic has been created. Now we have to publish the message onto this Kafka topic, and the consumer has to consume the message from this topic, right? So I'll just produce the messages, the Kafka console producer, right? The same command, right? Topic, right? Or what I can do is I can just copy from the repository which I have created and shared in my YouTube channel, right? The Kafka Zero to Heroes repository. So there I have mentioned all the commands, right? What you have to go, you have to go on to this folder, hands-on playground, and there is a commands.txt, right? So if you see, all the commands are available there, right? Now what we can do here is we can just do this command, Kafka console producer, right? And we can I'll just, yeah, we can use the same command, right? And we can just enter it, right? Now our console producer is running, right? What I can do is, let's also, I need to go into the Kafka container, right? Docker exec hyphen it Kafka bash, right? Now I can quickly copy the command, consumer command as well, from here only, right? Now let's assume this is one of the consumer command, right? Now, the Kafka console consumer bootstrap topic, and we have mentioned the property print key, and the print key is actually the partition key would be printed there, right? And the group with which we start the consumer, it's the payment service, right? Now let's start this consumer as well, right? Now as and when we publish one any message onto this order event topic, right, you can see the messages are being subscribed by the other consumer as well, right? Order 2, then I can do order 3, right? Then I can do order 4, right? Similarly 5, right? 6, right? So we can publish all the messages, right? And you can see the subscriber is continuously subscribing the messages, right? Now the one thing we have also seen earlier, for example, this is the consumer, right? If I want to again see all the messages, what all the messages are there from beginning, right? So what I was actually doing in the earlier cases, I was just doing from beginning, right? This is how I was supposed to get all the messages. So if you do this way, right, so you can see there are no messages being coming over here, right? If you again, right, if you pass this parameter from beginning without group, right, let's see, if you pass this without group, how it is being working. Yeah, now we are getting all the messages. Why it is so, right? Because what happens is, when you already have the consumer group, right? Kafka tracks each and every consumer group separately, right? When you provide the consumer group, Kafka knows, okay, this group has been delivered these many messages until this offset, right? But when you don't mention the consumer group, what happens behind the scenes? Kafka creates one consumer group from its own, right? I can show you, right? Kafka console, I can show you Kafka consumer groups, right? And the bootstrap server, right? And this is the list. I can show you the consumer group list, right? This was the consumer group which we have created, right? And this is the console consumer 49032, which has been created by the Kafka on its own. We have not created this consumer group. Why the Kafka has created it? Because Kafka mechanism works on the consumer group only, right? So even when you don't specify the consumer group, Kafka creates its own consumer group, right? So as sometimes in the real production data, if you want to see all the messages from beginning, right, there you can see some kind of rebalancing happening, right? So this is one of the reason whenever the new consumer group or new consumer is being joining to the Kafka cluster, so at that point of time you can see the partition rebalancing happening, right? So this is the reason for that. Now let's see let's publish few more messages, right? Let's publish few more messages, and our consumer is not running, right? Our consumer is down. I want to show you the consumer lag, right? I am just producing few more messages, order 8, order 9, and let's assume the order 10, right? So these three many messages we have published more when the consumer was down. Now let's see the consumer lag. How can we see the consumer lag? Let's copy the same command from here, the Kafka consumer groups. Okay, the command is not there. Okay, no worries. What I can do is I can just copy it, right? Kafka consumer groups, sorry, the Kafka consumer groups, right? And bootstrap server, and what we need to do, we need to provide the group, which group, the payment service, and let's describe this. And if you see, the current offset was 4, right? This is the partition 1 and partition 0, right? So how many messages the consumer has retrieved? Total 7 messages, 4 from partition 1 and 3 from partition 0, right? So 7 messages it has received. But once the consumer was down, how many messages we have published? 3, right? Now the current offset for the partition 1, the lag is 2. The lag is equal to log offset minus current and current offset, right? And similarly for partition 0, the lag is 1. So total messages which are pending, which has not been consumed by the consumer, is the sum of all the partition lags, right? So these are the 3 messages. That's how the consumer lag is, and that's how it works, right? Now let's continue with our discussion, right? Now each and everyone knows, okay, what is the consumer lag, right? Now what are the real problems? Now if you have consumer lag, what are the real problems, right? Let's discuss the use cases where actually consumer lag becomes a problem, right? Now let's assume you have some services, right? Service which gets messages from the Kafka topic, and the messages get processed and stored into the database, right? But let's assume due to some issue or any error in your consumer, right, either data gets lost, right, or due to there is some kind of null pointer exception, right, in your code, due to which the data gets corrupted, data doesn't get stored into the database. Or even if the null pointer exception is not there, there is some kind of calculation logic is mismatch, right, which is not processing the data in the correct order, right? So what would you have? You would have the corrupted data in the database. How you would have to fix this data, right? So that is where the Kafka replay comes in picture, right? So okay, with how you would fix this, you would fix the bug in the service, right, and reprocess the data. Now the challenge is how you would reprocess the data, right? Now the main problem is how you would know, okay, from this offset I want to replay the messages. For example, I can show you here, right? Here you have the current offset and the log and offset, right? Now the current offset is 4, right? As we have discussed in the earlier videos, the Kafka topic is like a queue which maintains the offset, right? Now the current offset is 4, but the log end offset is 6, right? So 2 messages are still pending, right? But how you would know, okay, from this offset, how the program would know, okay, from this offset we need to process it further, because it could be possible the data doesn't get saved into the database, right? So how it would know, okay, how it would know, there is, whenever you are consuming the records, for example in this case, right, for example in this case, I'll just show you property print dot key, and similarly property print dot offset is equal to true, right? So if you do this way, right, and you can just ignore this, right, and you can just provide the group, right? Group is the payment service, right? So if you this way, if you do this way, now what happens actually, you can see the offset is also coming, right? The offset 4, offset 5, offset 3, so these are the partition offsets, right? So whenever the consumer is consuming any messages from the Kafka topic, there is some kind of metadata is it also receives, right? So on which offset this message was, right? So what actually services can do, service can store this offset into the database along with the message, or into some kind of metadata they also can store, right? So that they can know, okay, this from this offset I need to start it next time, right? If the data gets data has to be replayed. So that's how you get the offset and you replay all the messages. Now the main question is how you would replay the messages, okay? So replaying the messages is simply just you need to reset the offset. When you reset the offset, the current offset is just be equal to that, and what would be your lag? Actually lag is log end offset minus current offset. So when you move the current offset, the lag becomes this much, and those many messages needs to be processed by the service again. I'll show you here. For example, what we need to see, we need to see how we can shift the offset or reset the offset. So that command also we can copy from my this video, from this GitHub repository. So for resetting the offsets there are two options. First is the dry run, because resetting the offset might be crucial in crucial sometimes, right? So Kafka has provided two options. Firstly, dry run. Once you are sure, okay, that this is the step you need to perform, then you can real execute it. So let me show you what I am telling, right? So for example, the here the current offset is now again 6, because we have consumed all the messages. Now I'll just clear it, and I'll just shift by -1, right? So let's see the command for this. Kafka consumer groups, that is okay. For which consumer group we need to reset the offset? The localhost is for just connecting to the Kafka cluster, and the group for which we need to reset the offset is the payment group, right? So we can do payment group, right? So that is simple. Or what I can do is I can just see what was the group which we have used. The group was the payment service actually, right? So what I can do here is I just need to change the group name, right? Now the group for which we need to reset the offset, for which topic, the order events, the reset offsets is the command, or you can say programmatically we can also configure the reset offset. And the shift by, this is the actual thing which has been given by the CLI, okay? You can shift by this many offset number, the -1 positive or negative, you can specify. Negative means it will shift behind, positive means it will shift after, right? Now let's run this command, okay? Let's run this command, okay? That shift by -f, okay, the group Kafka consumer groups, bootstrap server, localhost, okay. So what we need to do might be in copying some mistakes is there, because escape characters are being copied once I copy from the GitHub repository, right? So this is how you can try it out. That's my gut feeling. So what I can do is I can just dry run. So if you see now, the group for which we need to reset the offset, the payment service group, this is the topic and this is the current offset, right? This is the current offset. The current offset would become 1, or this is the partition and this is the current offset. The current offset would be 1 for this partition 1, and for partition 0 the current offset would be 3. Let's see what is the partition now. Let's see describe, right? Let's see what is the current offset. Current offset is 6, right? And log end offset is 6, right? So the lag is 0 for both the partitions. Now let me run the actual command to reset the offset, right? How I can do is the execute command, right? So what I can do is I can just run this command, and now I can again describe it, and let's see what is actually now, right? Just a second. Group describe. So if you see, the lag is 1, right? Now the current offset is shifted by 1. Now this is how simple it is. Now service can consume the messages, right? What are the pending messages? The pending messages is actually the current offset. From that offset the messages get replayed, right? This is how simple it is to reprocess all the messages, right? Now the second use case could be blue-green deployment, right? You are rolling a new version app with zero downtime. Okay, so first of all, many of the people might want to understand, okay, what is blue-green deployment? Blue-green deployment is actually, in this environment you have two environments. In this deployment you have two environment. One is the blue environment, which is currently live running in the production, right? And the green, which is the new version of your application or service, which will go live, right? So instead of updating the live system directly, what you do actually, you deploy the new version in parallel to blue. The new version is the green version, and you test and verify the green version with the production data, right? Once you are confident, you switch the traffic from blue to green. Blue just stays idle, or in sometimes it might not be required to be idle, because once you are confident, you can just directly switch the traffic to the green environment. And blue environment you can just consider as a backup for few days, so that if any issue comes, you can just reroute the traffic onto the blue environment, right? So that's how the blue green deployment is. Now the second use case is, for example, you are building a new recommendation engine model, right, which needs to be deployed and tested in production data before the actual release, right? So what actually happens, right? So if I have to, for example, the payment service which we have seen, right? So if you have to deploy the payment service, new payment service version, right, onto the production, how you will do that? So would you take a downtime? No. How would you achieve this? You would just deploy the new version of the payment service along with the currently version, right? Once you test all the things, once you test all the payment service with all the production data, you are confident, right? So in that case, you can just directly reroute the traffic onto this payment service, right? And you can just delete the other consumer group. So that's how simple it is, right? So it actually happens in the phases. So what happens in phase 1, right, as you can see on the diagram, right? So in phase 1 you can see the Kafka topic is there are two consumer groups, right? The old machine learning model worker and the new machine learning model worker, right? Both are running parallelly, both are processing the messages parallelly, right? Now once both are running process both are processing the messages separately into their own database, what happens actually, you compare the results at the end of for example, at the end of testing, right? And you fix any bugs whatever there in the new model version, and just once you are confident, okay, so what happens in the phase 2, you just point the new machine learning model and remove the old machine learning model. So that's how the zero downtime deployment you can achieve, right? With the new version you can test out the performance metrics and much more, right? So with both versions consuming the same stream, right, you can validate all the business logic, schema changes, performance metrics and much more, right, which you can compare in the results, right? So Kafka offsets give you precise control over which data the new version sees, right, and when it starts and how it processes, right? So I'll show you this use case also practically, right? Let me implement it, right, how I can do this, right? So for example, this is the payment service. I'll just clear this, right? So what we have, right, we have the payment service group, right? This is one of the group we have, right? Now what happens, we need to deploy the new application version, right? So what I can do is, I can just in phase 1 I have to in phase 1 what I have to do is, in phase 1 I have to replay all the messages, what for 7 days, 8 days, whatever the offset we want, we can replay the messages. How we can replay the messages? If we are starting the new application version, right? So how we can do that? So here, if I have to just provide the new group version, right? For example, the payment service v2, which is not existed, right? So in this what I can do is, from beginning, right, let's assume for this simple use case I just want to replay all the messages, all the 10 order messages from the beginning for this new consumer group, right? So that we can compare the results after, right? How? Now let's run this command, right? Now the beginning command is not correct, let me again do it, right? So from beginning, right? So if you see, now all the order messages should be there, right? Now how you get all the order messages? Because now the group name is different and you have provided the from beginning, so it is just a one of the option for replaying all the messages, right? Now you are confident, okay, the payment service, once you get all the data, you confident, you compare the results. Now this phase 2, that you sure that okay, the payment service v2 is working fine, I need to delete the old service group, right? So that's very simple, right? How you can do is Kafka consumer groups, right? So similarly bootstrap server, localhost, right? Then delete, right? And then you provide the group, right? And then you provide the group, then you just need to mention the group, the old service group is not much more active, right? So what you can do is, you can just delete the group. So if you see here, let's see the list again, how, what are the consumer groups there. Now if you see, the payment service v2 group is only there, right? So that's how you achieve zero downtime deployment with respect to Kafka consumers, right? So let's discuss more cases. Now the real cases, or the third case could be the, for example, the inventory change topic is there, right? The inventory change topic is there on, but the inventory service is down for, let's assume, 2 hours, right? But on this topic you get 1 million, 2 million, 3 million, whatever the huge surge of data onto this inventory change events topic, right? Now inventory service, when it comes up after 2 hours, it has to reprocess all the 3 million messages, right? Do you think it is feasible for inventory service to process all the 3 million messages? Okay, what would happen to the other use cases if the inventory service start processing 3 million messages? The CPU consumption, the resources will all be utilized for processing only these messages. What happens to the actual functionality of the inventory service? That will be spawned, right? That will not, you will, the other services might see the slowness, right? So there are few challenges how to tweak this behavior, right? So what happens is, actually, whenever this service, the critical services, right, when they go down, right, and they come up after some time, they, if they see, okay, they have to reprocess all the millions of events, what actually is the right behavior? Instead of reprocessing all the messages, there should be some source of truth available from where they can get the message on startup. For example, on startup, it can call product catalog API to get all the data, and once it get all the data, they can just simply reset the offset, whatever the lag was there. You just need to reset the inventory change events topic to latest, right? So that's how simple it is. No, if there is no lag, there is no message to reprocess, right? So on startup only, you just reset the offset to the log and offset, the latest, because it doesn't need to process all the messages, right? So after, once the data gets synced onto the inventory service, Kafka offset is set to latest, and only new inventory changes are processed. What are the new messages are there, that would be processed, right? So similar other use cases are there. I'll show you this use case also practically, but the similar use cases, the dashboard service, Airbnb, right? So there you see, okay, how many bookings are being happening, okay, this guy has checked in, right? So it has a real-time occupancy dashboard since service, right, which will consume messages from the Kafka topic, room booking events, check-in events, right, and it gets stored into their own database and show the live data, right? Now let's assume the dashboard service is not up and running for some time. So similar behavior, you have the millions of events coming onto this topic, and dashboard service, once it comes up, it sees, okay, there are a lot more data to process, right? It would be very hectic for it to process rather than compromising its own functionality, right? So what it will do is, it will just reset the offset to the latest, and then it will just try to get all the data from the backend in one single call, or in export import functionality. There are so many other mechanisms, right? So export, you can just export the data, and the dashboard service can directly import the data wherever it needs to be imported, and just it is up and running fine. So the other use case also could be the rebuilding Uber driver state, right? In Uber application, driver availability service is there, right, which will keep publishing messages whenever the driver is traveling, right? So currently I'm on this geolocation, so all the messages are being sent over onto this Kafka topic, right? Driver status events, let's assume this is the Kafka topic, online, offline, start, trip started. So there are many messages, right? So but there is a driver aggregator service which consumes all the messages and gets stored, okay, where the driver is there, where the driver is located now, whether he is offline or online. So all these are there, but when the driver availability service comes up after few hours, right? So the Kafka topic could have lot more data to process, right? So in this case also, this service can directly get all the data on startup, and you can just reset the offset to the latest, right? Now how to do it technically in the programmatically, I will show you when we will start working on new project in Java, right? Spring Boot Java, the complete Kafka project, which will be covered in this series, right? So there you can just consume provide this option, seek to end is the functionality there. There you can provide the topic partition, or the other way is you can configure the auto reset offset to latest, right? Now let's see the practical use case, right? So how we can reset the offset to latest, right? Now for example, I can just publish few more messages, order 11, right, then 10, order 12, right? Now if you see here, let's see the lag, let's see the consumer lag, right? I want to show you the consumer lag first, right? Consumer groups, then group, the payment service v2, right, and then describe, right? So if you see, there is a lag of two messages, order 11 and order 12, right? Now what we can do is, instead of processing, let's assume this payment service is down, right? It comes after 2 hours, and the lag is close to 1 million, 2 million, 3 million, whatever the huge number you can take it, right? Now how to clear this lag so that the payment service can consume all the data or get all the data on startup from the external system where it can get all the data, import all the data into their own service for starting, right, for processing the new messages. How it can do is, it's very simple actually, right? So it's very simple. The consumer groups, right, the reset offsets, right? So here what we can do is, there is an option to latest, right? And if you provide this, right, if you provide this, we just need to provide the payment service v2, right? So if you do this way, right, so you would see, okay, the new offset would be for this topic, for this partition, actually it would be 6, the current offset. Earlier the current offset was 4, right? Now with this command the current offset would be 6. Let's see whether it is really 6 or not, right? So the current offset is 6. Now all the messages are clear, the lag is clear. So this is how you handle all these cases, right? Now Kafka provides other options like shift by. This is one of the option. Then the two earliest is one of the option, where from where you can get all the messages from beginning. Two latest is one of the option where you can reset the offset to the all the latest offset, right? Then the other option is duration, right? Duration is the period frequencies, right? So move the offset by 5 minutes, right? 5 hours, you can mention all this. The other option is, you can provide an option to reset the offset to a particular date and time, right? So this is how you can achieve zero downtime deployment. Then the other thing we have seen, the how to clear the consumer lag, how to handle high surge of request when the consumer service up after some time, right? So that was all I had planned to cover. So please like, comment and subscribe on my channel, right, if you really like my explanation, right? So I do post regularly one LLD problem in every week. For example, in last week I have published publisher subscriber model pool based, right? So I have done all the code, right? And yeah, this is the least I can ask. Please do watch other videos on my channel. The multi-threading series zero to hero series is also going in parallel with respect to Kafka. So there I am covering all the major questions or major multi-threading concepts, right? So very detailed, very in-depth, very practically implementations, right? So see you next video. Thanks a ton. Thanks.